this might be the best looking code you've ever seen in your life, it might not run the best. Otherwise, it might not have the best efficiency. So let's analyze it a little bit. This is a contact tracing program I wrote that simulates virus transmissions under different circumstances. So let's kind of look at this. This is a global variable called people. It's a list created with the list comprehension. So I put for I in range 10, I'm making 10 turtle objects. So this is creating new turtles, and they will be stored at people at 1, people at 0 first, people at 2, etc. These functions here, this one moves a person. So that is a item in the list here, a turtle, a specific turtle. I could have said that, but I like the simulation analogy here for person. It's supposed to represent a person. So it takes this person and moves it left by a random degree. It moves it forward then by a random amount, either forward or backward. So between negative 10 and positive 10, if amount happens to be 10. Okay, this function here detects a collision. So it checks to see if a person is within apart pixels of all other people. So it takes the people and then it asks which neighbors, or it goes down the list of people and calls each other person a neighbor. Okay, and then this statement, if person is not neighbor, this prevents person and neighbor from being the same. Because if it analyzes itself against itself, then yeah, those two people will have the exact same coordinates, and so that will be considered colliding with each other. But that doesn't make sense. It can't collide with itself. So this prevents self collisions. If person is not the neighbor, then check. If the distance between the person and the neighbor is less than my standard, then color that person red. That person is sick. So if I'm going to spread people out, I'm going to spread all the turtles out at first. And then if they get too close to each other, they automatically have COVID. That's not really how COVID works. It's got to start somewhere. But that's how my simulation works. If people get too close, then they contract COVID and they turn red. Okay, this is a distance calculator. Calculates the Pythagorean distance, the square root of c is equal to the square root of a squared plus b squared. It's Pythagorean theorem, right? So here's the a squared. It's the absolute difference of the x coordinates, and this is b squared, the absolute difference of the y coordinates. Notice I didn't have to use math.abs here. The square does that for me. Okay, so if this is a negative distance, square becomes positive distance. Again, this is a backslash that just allows me to continue on the next line, and this way it's a little bit lined up. It's a little easier to read as opposed to that. That's kind of hard to read. So let me go back. There we go. Okay, so in the main code, it sets up the people in random locations. So it takes every person, sets that person's speed to 100, and sets that person's color to green, and picks up that person's pen, and then it goes to a random space. These are kind of my bounds in my box. Okay, so it goes to a random space in the box, and this is where everything happens. Okay, so this is the setup, and this is where it happens. So for I and range 100, I'm gonna have 100 different steps in my program, 100 different movements. So for the first movement, let's look at each movement as a whole, or individually rather. So for each person and people, so it goes through the list of people. So it actually is a nested loop, which is totally fine. So for each person and people, check the collision. Check the collision. Remember, collision checks for that person if they collide with any other person. So if they are colliding automatically with any other person, if they're close to any other person from the setup, then this will detect it within 50 pixels. That's how I set it up here. And then, so it detects all the collisions if they are there. And then for each person and people, it moves them. So move, like I said, is a random turn and a random amount. And in this case, I'm sending 20. So I have all these parameters. I have these details of my simulation going. So they contract COVID if they're within 50 pixels of each other. They move 20 pixels at a time. What else did I set up? There are 10 of them total in this space. This is 400 by 400 space, I think. Where's my random setup? Here it is. Yeah, 400 by 400 space. Okay, so let's run it and we'll see what happens. I need a little bit more room here, I think. Let's run it. Yeah, I'm zoomed in a little too far. Let me zoom back out. There we go. Okay, so I've got a few COVIDs. Let me move me. Get out of here, me. So yeah, these people already collided with each other and they turned red. And this guy's getting close. He's getting close. Is he gonna get? Is he gonna get sick? Yes, he's sick. So if I were to let this run forever, I don't know. What do you predict? Do you think it's gonna You think some of these people will go off the map? I did not do any redirection. I didn't say if you go outside of the bounds, negative 200, 200, negative 200, 200, then you need to return back. See, this guy went off the bounds. Oh, and then it stopped. So that was my 100 steps. So I ended up having, I think, 2 people survive. Oh, there's a couple more. 4 people. Looks like 4 people survived because these guys ended up way down here. So I think it's kind of fun. You could tweak all of these numbers. Please fork this code. I'm going to put the link in the description. Please fork this code and tweak these numbers, and also add more features to it. So add a counter. How many people are sick after certain steps? What happens if they move less? What's kind of the peak amount? So that they're still moving. They're still out doing things in the social world, but they're not getting sick. So yeah, that'll be a fun simulation to do. Have fun.